Just as our streets make up our locations, so does the switches. The switches makes up our networks. My name is Tabama Kobe, the founder of Technology for All Academy, a division of Above Supply and ICT Solutions. Our topic for today will be about switches. For those who don't know what a switch is, here I'm having a 24-port switch. It's a Cisco switch. And then again here I'm having a 3-port. This is an all-in-one. It's a router, it's a switch, it's an access point, it's even a firewall. The first port is for where our internet goes in, and then we have 2 switch ports on this router. And this one also is a total link. That one is a microtic. This one is a total link. Also the same concept. That's where your internet goes in, and then we have 4-port switches. So for those who don't know what is a switch is a central device or central point for our local area network. Our clients and devices plug into the switch using what we call a network interface card. Our Ethernet cable will plug into our network Ethernet, into our network interface card, and the other point will plug into your switch port. This is the connection that makes our devices to be connected to our local area network or to our network. Switches, unlike hubs, they are intelligent. They use layer 2 for communication, whereas hubs use layer 1 for communication, and they only know how to broadcast or regenerate signals. On the other hand, switches, they can broadcast, multicast, and do unicast. So each port on a switch, it's a collision domain. It can send and receive at the same time. Whereas on the hubs, each port can only send or not end or receive at a time. A hub has one collision domain, whereas in the world of switches, each port is a collision domain. And broadcast domain is only one broadcast domain, and also in switches it's also one broadcast domain. That's if we don't configure things like VLANs and everything. If we configure VLANs, then we will be able to have more than one broadcast domain on a switch. But for now, we just want to talk about the basics of a switch. More on VLANs and other stuff at the later stage. Which brings me to my point. As we said, a switch is intelligent. We are able to configure a switch, but we can't configure a hub. And a switch learns MAC addresses. That's how it communicates with the devices connected to it. It learns their MAC addresses as they communicate to one another. So the job of a switch is to be the central point for communication and it's also used for resource sharing of resources, things like print server. We might have maybe 10 clients on our network, or even more than that, but I just want to make an example with a small network, just a Soho network. We might have 10 clients sharing one printer, and all of those clients are printing to one printer, and that's possible because of what? They are all connected on the same network or on the same switch. So another thing, a switch uses carrier sense multiple access with collision detection. It's able to detect when there is a collision, whereas on the side of a hub, it's collision avoidance. And as I've said, a switch can also do half duplex or full duplex. Full duplex, as I've said, meaning full duplex is it can send and receive at the same time. For some of the things that maybe I forgot to mention, I will mention them as we progress with our topic when I show you the how or the practical side of how a switch works. Let's start making our practical example of how a switch works using Cisco packet tracer. I already have my pre-configured topology on the screen. So I'm going to my laptop that's connected to the console cable, and let me go to terminal, open on terminal, press OK, then press enter. As we said before, a switch uses layer 2 technology, whereas a hub uses a layer 1 technology, and a switch it's more intelligent than a hub because you can configure it. It has memory, it has commands that you can run it, so it's more intelligent than a hub. So right now I'm gonna give a command to my switch, which is show MAC address table, then press enter. As you can see, right now our switch doesn't know any MAC address. There's nothing on the MAC address table. So for it to learn MAC addresses, there must be traffic that passes in the switch. And the switch, after learning the MAC address, it takes 5 minutes for it to remember that MAC address. If that MAC address is not, what can I say? If that MAC address is not active for 5 minutes, then our switch will forget that MAC address and it will repeat the same process when that client wants to do something on the network. So right now, as we saw, our switch doesn't know MAC addresses. I have to create some traffic for it to know MAC addresses. Firstly, we are on real mode. Let me go to simulation mode and open our event list, and then I'm gonna make traffic by pinning another computer. So on my laptop I'm giving a command pin 10.10 dot 1 dot 13, enter. Okay, let me minimize it. As we can see, on our event list, we have the first two packets that already went through. This one, the first one, ICMP, when I click on it, let's see the OSI model. It shows us on the OSI model, it's what layer 3 is the command that I gave to my PC, meaning from 10.10.1.10 I'm pinging 10.10.1.30. ICMP, it's for echo request, all those things like ping, it falls under the ICMP. So let me close it again, and then let's see this. Let me forward my packet. Okay, my packet is now at the switch. As you can see, there's another event 3AAB. That's my last 4 digit of my MAC address to switch to, and the message is what? Up. Let's start with the first one. That was from my computer. As you can see, when I open that message, we can see that layer 2 Ethernet header from my computer or from my laptop to all of the MAC address. The MAC address, it contains all Fs, meaning what? We don't know our destination MAC address. So since we don't know our destination MAC address, what we need to do is to send an up message. An up message is a broadcast message. It's a message that will be from my computer to all the computers or all the clients that are connected to my network except me. Meaning I won't get the message because I'm the sender, but all the clients that are connected will get the message, and only the IP address that I'm pinging will reply to my message, and the rest of the clients will drop the message since the message is not intended for them. As you can see on our layer 1, we have port fast Ethernet 0. That's our outbound, meaning it's from our laptop going to our switch. Okay, let me close it, and then let's inspect the following packet. The following packet is subset. The following packet from port fast Ethernet, from my laptop to port fast Ethernet 0/4, meaning my laptop is connected on fast Ethernet 0/4, and then going outbound on layer 1, we can see that it's been flooded to fast Ethernet 0/1, 0/2, and 0/3. As we can see, I have 4 clients on my network. Why is it not flooded from that other laptop? Because as you can see, it's only showing 4 clients. Well, the reason is because that client is connected on a console cable, and a console cable connects to a serial port. So it's not connected to an Ethernet port. That's why we don't get any messages or any packets going to that laptop. That laptop, I use it for configuration. As in, when you configure your switch for the first time, or your router for the first time, you have to plug in your console cable, and the other end must go to your serial port, which in nowadays we extend with serial to USB port, because our laptops Nowadays they use USB ports. Okay, let me carry on. Let me close, and as we forward, we can see that the way that we inspected the packet, it went to all the ports, meaning 0/1, 0/2, and 0/3. So let's inspect this one. Yes, as you can see, it arrived at 10.10.1.30. As you can see, the MAC address, it's our MAC address, and the destination MAC address is still apps, and the message is an app packet. As I've said, it's broadcasted to all, but the other clients dropped it because the message was not intended for them. Only 10.10.1.30 will respond to the message. And we can see that the switch, as we said in our previous episode, the switch is using layer 2, and we can definitely see that from this practical that we are doing. Let me close it again and do another packet forward. You saw it's from my laptop to the switch. Now let's inspect it. Right now, as you can see, it's from, okay, it went in for fast Ethernet 0/1 from 10.10.1.13 laptop to a port that it's connected to on the switch. And then from there, it goes to port 4. Port 4 is connected to which laptop? Is connected to 10.10.1.10. And as we can see on our MAC addresses right now, we don't have apps anymore. We have our laptop's MAC addresses, meaning our source MAC address and our destination MAC address. Okay, capture forward. The message arrived at our destination, and as you can see, if I open it, it's arrived at fast Ethernet 0. And we saw that the message was from laptop 10.10.1.13 to laptop 10.10.1.10. It didn't go to other laptops right now. So let me go back. Let me go back to my switch, to my telnet interface, and then give that command that I gave before again. Let me give it show MAC address table, and then let's press enter and see what's happening. And as we can see right now, our switch has learned 2 MAC addresses. It has learned our source MAC address and our destination MAC address. The other 2, it didn't learn them. Why? It didn't learn them because they didn't reply back. They got the app message of all apps, and then because the message was not intended for them, they dropped the packet. They didn't reply back. So that's how a switch learned MAC addresses. And right now, I want to take these very same laptops, connect them to our hub here, and see what will happen if we do the same thing with the hub. Okay, let me connect them. And then I go again. Let me punch an up key so that I can offer a pin command. We are pinning 10.10.1.13 again, Now let's do that. Let me minimize it again. Let's check our event right now. Capture forward. It goes to the hub. Goes to all the computers or the laptops. And then let's check our playback if it will be the same as the switch or if it will be different. Let's see. It goes to the hub, and then let's see if it will only go to 3 ABB or 10.10.1.10. Capture forward. It went to all the laptops again. Why is that? That happened because of what? Because of hub uses layer 1. It only uses, it repeats the signals. It doesn't know about your unicast, your multicast, all those. It only knows up, which is a broadcast message. It only knows how to broadcast, regenerates the signal to all the clusters connected. And with all that said, I would like to say thank you, and I hope you enjoyed this example and you learned a lot about what a switch can do and what a hub can do.